Like a little faster, like, Professor Baldwin, I need help with this question. Okay?
Okay.
Okay, go. 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 You didn't do anything.
You look good, Professor Baldwin.
Shh. Yeah.
Is it recording right now?
No.
Professor Baldwin, I need help with this question.
I heard someone needs help with the question. Is that right?
That's right.
Professor Zach's here. So before I delve into this beast, I just want to say that the only way I'm able to teach other students is because I was taught by the most amazing teacher ever, and the most beautiful teacher ever, Miss Taylor. She's awesome. I'm only able to just be a beast at math because of her. She's so beautiful. Why? Can you see that?
Nope.
No?
No.
It would be a shame if this was being recorded and I got it wrong and it would be on YouTube. So our givens are y equals negative x squared over 9 plus 1 and y equals 0. When we graph this using our calculators, because we can do that now, 21st century, we can use calculators. We notice this is oh gosh. Oh my gosh. Okay, we know it's a semicircle. And these intersections are at plus and minus 3. Negative 3, positive 3. Semicircle. We know in a semicircle, it's just 1/2 the area of a circle for the area. So 1/2 pi r squared. What we know now is that not r, don't get this confused. This means something here. This means something with the semicircle. This is not r though. This right here is d. D equals negative x squared over 9 plus 1. Diameter. Diameter. So what do we do to get r? You divide by 2. Negative x squared over 9 plus 1 all divided by 2. Did you get that far?
Mm-hmm.
You're a genius. Let's go ahead and plug it in. A equals 1/2 pi, this beast right here, negative x squared over 9 plus 1 divided by 2 squared. Right there. So that's a cross-section problem. We know how to solve those. Let's integrate. But first, what do we see? 1/2 pi. What do you think that is? That's right, it's a constant. So what we're going to do is bring that out in front of whatever we're doing. What do you think the bounds are? X. So we're doing a left, right. Oh yeah! Plus minus 3. Wow! So we're going to go negative 3 to 3. Lower bound, upper bound. And then we're going to plug in the beast. Negative x squared over 9 plus 1 over 2 squared. dx, this is an integral. You may want to plug it in your calculator, but you're going to be like, wow, negative x squared over 9 plus 1 divided by 2 all squared. Parentheses could get a little complicated. You know what? You're right. Parentheses can get complicated. So let's simplify this a little. Negative x squared over 9 plus 1 divided by 2. Let's take this over here. We know that's 1/2. Let's keep that. Negative x squared over 9 over 2 over 1. Because we know right here, x squared over 9 is a numerator, denominator here. 2 is the numerator actually because it's over 1. So this right here is over that. So what do? We multiply by the reciprocal. And we get negative x squared over 18 plus 1/2. That's right. So 1/2 pi negative 3 to 3. Plug in the simplified version so it's a little easier to get in the calculator. You can get common denominator and all that, but man up and put in the calculator with some parentheses. Just man up. It's alright. We're not done though. You square this bad boy. So after we do that, we get 1/2 pi times what our calculator figured out. But we all know how to do this by hand. But we also have a calculator. So we also know this is 0.8, of course, because who doesn't know that? And we're going to multiply that by 1/2 pi. And we know 0.8 times 1/2 is 0.4 pi. And it is alright to leave it like that in my book, because that's what Miss Taylor would tell me. You know, if you're on a free response and you've gotten to where everything's plugged in, don't solve it. You just increase the risk of making an error somewhere. So 0.4 pi. You don't want to make an error multiplying 0.4 times pi. Just know that this is a constant. You know, it's really just plugging in. Identify, you know, you have to know what's happening here. This is a semicircle. It's a god-awful semicircle, but it's a semicircle, I'll tell you that. And it's intersecting, well, the zeros are at negative 3 and 3. Those are going to be the bounds. It's integration. You know that 1 over 2 pi is a constant. Bring it out. Don't mess up with it. It's just more crap to deal with. And, you know, simplify it down a little. That's pretty tough to put in a calculator with parentheses. The TI-84. What does that look like to you? Besides a semicircle. Immediately when I think of something going over, I think of a lot of objects placed somewhere in an upside down bowl. Maybe a dome. You know, we see a lot of sports arenas. Just a dome. The ground right there. What does that look? That looks like the horizon. Sun setting, sun rising, you know. Semicircle is a magical thing. Whenever you see the sun rising, just think y equals negative x squared over 9 plus 1. You're beautiful, Miss Taylor.